Let's look at this episode of Modern Maths Bites. A dice is thrown, find the probability of getting an even number or a prime number. Okay. When you throw a dice, there are 5 possible cases. 1, 2, 3, 4, 5, 6. And of these, which are to be counted? Prime, 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 even, even. 5 of them are counted out of 6. So answer has to be option C, 5 by 6. Next, there are 4 marketing electives: consumer behavior, sales management, services management, and brand management, out of which each student has to choose at least 3 electives. Further, any student choosing brand management has to necessarily also take consumer behavior. 120 students have opted for consumer behavior, 120 blah blah blah. Find the number of students who opted for both sales management and services management. Okay. This is a 4 set Venn diagram that needs to be created. What are the subjects? Consumer behavior, then sales management, then services management, and finally brand management. And out of which each student has to choose at least 3 electives. So at this time, I can happily go on a spree and cancel out a lot of regions. The only regions that remain are exactly 3 or all 4. Further, any student choosing brand management has to necessarily also take consumer behavior. So brand management's existence without consumer behavior is impossible. So this grouping will not exist. So this is all. Brilliant. Now, 120 students have opted for consumer behavior. This 120 is very interesting because this 120 is effectively all the students. Everyone is present within consumer behavior. This 120 is as good as all people. Okay. 105 have opted for sales management. Now, sales management only has these 3 regions. These 3 regions. Can I change the color of the pen? Yes. Sales management is only these 3 regions. This one here is left. And I know total people are 120. If these 3 are 105, this region here should be 15. This is identified. Okay. And 100 for services management. 100 for services management. Now, services management is which regions? Let me use a different color. Services management is given by this here, and this here. These 3 regions add up to 100, which means this number here has to be 20 because the total was 120. And 95 for brand management. If there are 95 in brand management, out of the 3 regions of brand management, 15 and 20, 35 is known. So this has to be 60. Once this is identified as 60, 60 plus 20 gives me 80, 80 plus 15 gives me 95. Total I know to be 120. So this has to be 25. So now, finally, what does the question ask me? Find the number of students who have opted for both sales management and services management. Opted for both sales management and services management refers to these 2 regions. 20 plus 60, answer is option A, 85. Next, an experiment consists of tossing a coin 10 times successively and noting the result after each toss. How many distinct outcomes of the experiment are possible such that exactly 3 of the 10 toss results in a head? Basically, we need head, 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 and then followed by 7 tails. Not necessarily in this order. Anytime these are rearranged, I get an acceptable case. So my storyline here has to be 10 factorial by 3 factorial, 7 factorial. In fact, this is the building block of binomial expression in probability. So we get 10 into 9 into 8 by 6 because 7 factorial is cancelled out. This is gone. This is gone. Left with 12. So 120, option D will be the answer. Next question. The following image is that of a road network between 2 towns A and B. A person starts from A and reaches D by the shortest route. He further returns from B to A, again using the shortest route possible. How many distinct paths are present for a person to travel from A to B and back to A using the shortest possible route. Two paths are identical only when the entire path is made up of same routes. Okay. So in terms of thinking, what I want you to do is see this person in order to get to B, somebody is starting off at A. In order to get to B, what does this person need to do? 1 right, 2 right, 3 right, 4 right, 5 right, and 6 right. 1 up, 2 up, and 3 up. Basically, he has to go up, 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 right, 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 right. 6 rights and 3 ups. Anytime these are rearranged, you are getting a new route altogether. So in how many ways can these be rearranged? 9 factorial by 3 factorial, 6 factorial. And this is only the path from A to B. The question was asking me from A to B and back. So this entire thing will also get squared. This entire thing will also be multiplied by itself because the number of ways of reaching from A to B and reaching from B to A, they're going to be identical. So this, let me simplify, will turn to 9 into 8 into 7 by 6. So cancel, 12. So I get 84. And now 84 into 84 I need. 84 into 84 if I need, my answer has to be greater than 6400. Only option A will suffice. While I've got it, this is the count of paths that I can have from A to B, and for return from B to A, there will be another 84 paths. So final answer has to be 84 into 84. I'm not doing the maths for this because the options are such that there is only one option that can be 84 into 84. It has to definitely be greater than 6400. Answer has to be that. Another way you can look at it is unit digit has to be 6. There is just one option with unit digit 6. Okay, last question. In a school, 120 students play cricket, 90 play football, and 75 play hockey. Further, 50 play cricket and football, 40 play cricket and hockey, 25 play football and hockey. If the total number of students in the school is 200, what is the maximum number of students who can play all three games? Let me make the Venn diagram. Cricket 120, football 90, and hockey 75. 50 play cricket and football. So let this be 50. 40 play cricket and hockey. And 25 play football and hockey. So let this be x. This will be 50 minus x. This will be 40 minus x. This will be 25 minus x. So this will be x plus 10, x plus 30, and this will be x plus 15. Altogether, I have 120 people here. 15 plus 25 plus 10, 50 more, 170 people plus x. So outside, we will have 200 minus 170. So outside, we will have 30 minus x. These many people. Now I know the precise number of people, in terms of x at least, precise number of people at each of these locations. Again, the idea is because each of these regions are populated by a whole number of people, x has to necessarily lie in the range 0 to 25. If x is greater than 25, see what would happen. The region here will turn negative, and we cannot have that. We cannot have count of people as negative. So the possible range for values of x has to be 0 to 25. And x was itself the number of students who can play all three games. So what is the maximum possible value of number of students who can play all three games? Answer is option C, 25. That will be all for this episode. Hopefully you had fun. Okay, bye.